All right, today we're going to solve quadratics by factoring. So in order to do that, you want to move all your terms to one side and set the equation equal to 0. You can factor. Remember, there's differences of squares, sum of cubes, differences of cubes. We may factor with the vary method, grouping. So according to what the problem is what method you will use. After you factor, you will set each factor equal to 0 and then solve for each x value. Write your answer as a solution set. Okay, remember the degree tells us how many answers that we are possible. So here in this first one, we always start by looking for a GCF. So we can take out an x, and that would leave me x plus 9 equals 0. Okay, so we have two factors here. We have the factor of x and x plus 9. So we're going to set both of those equal to 0. And then we're going to solve for x. So the first one's done for us. We would subtract 9, and x will equal negative 9. Then we're going to put our answer in a solution set. So x equals negative 9, comma 0. So that tells me that when I plug negative 9 back in, it would check out and our 0, and that's our two answers to that function. Okay, you might try number 2, pause the video and try it, and then come back. Okay, so we're going to take out a 4 and an x, and that's going to leave me x minus 2 equals 0. So we have 4x equals 0. We're going to divide by 4, x equals 0. And then x minus 2 equals 0, so x is going to equal 2. Now some of you can do this without doing the process of writing those two factors down. Just be careful because sometimes you will leave out a factor, especially these at the beginning of the x. Okay, so we're going to finalize by putting our answers in a solution set, 0, comma 2. Okay, here we have a difference of squares. So when we factor this, you should know it becomes x minus 2 and x plus 2 equals 0. If you remember from the previous lesson, you could have done this using the square root method. So if you recognize that, there's multiple ways that you can solve some of these equations. So when we set the factors equal to 0, we're going to get x equals 2 and x equals negative 2. So our final answer in our solution set would be x equals positive and negative 2. I hope you realize now that we've been factoring now for about 4 units, how important that factoring was in unit 3. So now we're going to do this. This also is a difference of squares. So we have 3x minus 5, 3x plus 5. And here's where you need to be careful if you're not showing your work, because a lot of times here you will come out and you'll say x equals 5 and negative 5, and you forget about this 3. So just be careful there. So we have 3x minus 5 equals 0, 3x plus 5 equals 0. We're going to add 5, and we get 3x equals 5. Divide by 3, and x equals 5/3. Subtract 5 here, and 3x equals negative 5. Divide by 3, and x equals negative 5/3. So our final solution, x equals plus or minus 5/3. All right, so here we have a trinomial when a is 1. So we are going to just ask ourselves what multiplies to give me positive 21. But we'll combine and add to give me negative 10. And hopefully you're getting quick about this and you realize it's x minus 7 and x minus 3 equals 0. So then we have x minus 7 equals 0, x minus 3 equals 0. So x is going to equal 3 and 7. Okay, remember GCF is the first thing we always check for, so we're going to take out a 2 here. We get x squared minus x minus 12 equals 0. And when we factor this, you should know quickly it's x minus 4 and x plus 3. Now, if we set 2 equal to 0, first of all, 2 does not equal 0. The other thing is 2 does not have an x, so there's nothing to solve for there. So that's not going to be part of our solution. Okay, so just realize the 2 does not allow us to solve for an x. Okay, x minus 4 equals 0, so x equals 4. X plus 3 equals 0, so x equals negative 3. So x equals negative 3 comma 4. Okay, so here, the previous problems were already set equal to 0 for us. So now it is not equal to 0. So the first step was to set everything equal to 0. So we need to move this x plus 4. Okay, so if you remember when you were solving equations, you always do inverse operations. So this is a positive x, so we're going to subtract x, and we're going to line it up over here with its like term. Then we're going to subtract 4, and we're going to subtract 4. Hopefully you can do this in one step. You should get to that point now to be able. So we get x squared plus 10x plus 25, because 11 minus 1 is 10, 29 minus 4 is 25. This is 0, this is 0, so it equals 0. Always check, because you may have made a mistake, and if you had added 4 over here, you wouldn't get 0, you'd get 8. So do that checking. All right, so this becomes x plus 5 and x plus 5. So those two are the same. So if I set them equal to 0, I'm going to get the same answer. So in this case, I get x equals 5. Okay, so hopefully you remember we talked about when you have like x plus 5 and it's squared, that's going to cause the graph to bounce there. And that's the reason we only have the one solution. All right, here we need to get it equal to 0. So we're going to subtract 2. And we're going to add 3x. And I get 4x squared plus 44x plus 96. That's 0. And that's 0. Equals 0. Okay, now we're going to check for a GCF. We can take out a 4. X squared plus 11x plus 24 equals 0. Okay, so not always will this have a as 1, so make sure that if you can't take out a GCF, you remember how to do the Berry method or the grouping. So we have 4x plus 3, x plus 8 equals 0. So again, we don't have to worry about that 4. X plus 3 equals 0. X plus 8 equals 0. So x equals negative 3, negative 8. So we're going to write it in our solution set. Negative 8, comma, negative 3. Okay, so that is solving quadratics by factoring. Check your plan book and do what your teacher assigns. Have a great day.